Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is still about exponent rules, and this is the part 2 of this topic. If you did not yet watch the first part of this topic, find episode 80 and you may watch it after this video. Okay, in this episode, I will be teaching the third and the fourth exponent rules. Let's have the third exponent rule. This is what we call the power of quotient property or rule. This rule focuses on what happens to the quotient when it is raised to some power. Okay, in this rule, our base must not be equal to 0. M and N, or the exponents, are natural numbers. Power of quotient property or rule has three kinds. The first one is the exponent of our dividend is larger than the exponent of the divisor. The second kind is the exponent of our dividend is equal to the exponent of the divisor. And the third one is the exponent of the dividend is less than the exponent of the divisor. Okay, what will we do if the exponent of the dividend is larger than the exponent of the divisor? Okay, the rule is we will just copy the base, then subtract the exponents. Okay, how about if the exponents are equal? If the exponents are equal, then this is equal to 1. And then the third one is if the exponent of the dividend is less than the exponent of the divisor. So this is equal to 1 over a raised to the power of n minus m, or the answer is a fraction. Okay, let's give an example to each kind. Okay, let's start with if the exponent of the dividend is larger than the exponent of the divisor. So we have here x raised to the power of 5 divided by x raised to the power of 2. So 5 is greater than 2. So the rule is same bases, and this is division. So we will just copy the base x, then subtract the exponent. So 5 minus 2, this is equal to 3. So we have x raised to the power of 3. Okay, I will explain further how did I get x raised to the power of 3. We will write x raised to the power of 5 divided by x raised to the power of 2 as fraction. So this is x raised to the power of 5 over x raised to the power of 2. X raised to the power of 5 is x times x times x times x times x. Okay, over x squared is x times x. Okay, if we will simplify, this will be cancelled, this will be cancelled. So we only have x times x times x, and this is equal to x raised to the power of 3. So if the exponent of our dividend is larger than the exponent of our divisor, we just need to copy the base, then subtract the exponents. Okay, now let's give an example if the exponents are equal or the same. We have here x squared divided by x squared, and according to this rule, this is equal to 1. Okay, let's explain further. How did we get 1? Okay, write x squared divided by x squared as fraction. So this is x squared over x squared. X squared is x times x over, since this is also x squared, so this is x times x. If we will simplify, this will be cancelled, this will be cancelled. So this is equal to 1. Okay, take note, this is not equal to 0. Because if we have a fraction 2 over 2, 2 over 2 is equal to 1. This is not equal to 0. So this is just the same concept. Okay, let's also give an example if the exponent of the dividend is smaller than the exponent of the divisor. How did we get this fraction? How did we get this fraction as the answer? Okay, we have here x squared divided by x raised to the power of 5. Okay, let's write this one as a fraction. So this is x squared over x raised to the power of 5. X squared is x times x. X raised to the power of 5 is x times x times x times x times x. Okay, let's simplify. This will be cancelled. This will be cancelled. So, in the denominator part, we have x times x times x. And this is equal to x raised to the power of 3. Okay, how about the numerator? Our numerator is 1. So, the answer is 1 over x raised to the power of 3. So, this is a fraction. Okay, this is a fraction. Okay, now let's answer this simple activity. Okay, the first one is 2 raised to the power of 5 divided by 2 squared. Okay, same basis. This is division. The exponent of the first one, or the exponent of our dividend, is larger than the exponent of our divisor. So copy the base 2, then subtract the exponent. So this is 5 minus 2. So 5 minus 2, 3. So the exponent is 3. So we have 2 raised to the power of 3. Okay, what about the second one? A raised to the power of 6 divided by a raised to the power of 4. Okay, this is division and then same bases. So we just need to copy the same base A. Then 6 is larger than 4. So subtract this exponent. So 6 minus 4, 2. So we have a raised to the power of 2. Okay, the third one. 2 raised to the power of 3 divided by 2 raised to the power of 6. Same basis, and this is division. The exponent of our dividend is smaller than the exponent of our divisor. So our answer must be a fraction. So this is equal to 1 over 2. Okay, 6 minus 3. 6 minus 3, so our exponent is 3. So we have 1 over 2 raised to the power of 3. Okay, I'm gonna explain again further. How did I get 1 over 2 raised to the power of 3? Okay, 2 raised to the power of 3 divided by 2 raised to the power of 6. Let's write this one as fraction. So 2 raised to the power of 3, 2 raised to the power over 2 raised to the power of 6. 2 raised to the power of 3 is 2 times 2 times 2. 2 raised to the power of 6 is 2 times 2 times 2 times 2 times 2 times 2. Okay, if we will simplify, this will be cancelled and this one also. So we have 2 times 2 times 2 in the denominator part, and this is equal to 2 raised to the power of 3. So numerator is 1. So we have 1 over 2 raised to the power of 3. Okay, what about this last one here? A squared divided by a raised to the power of 7. Okay, the the exponent of our dividend is smaller than the exponent of the divisor. So our answer is a fraction. So this is equal to 1 over a, so 7 minus 2. 7 minus 2, 5. So the exponent of a is 5. So we have 1 over a raised to the power of 5. Okay, how did we get again this one? Okay, let's explain further. Write this as fraction. So a squared over a raised to the power of 7. A squared is a times a. A raised to the power of 7 is a times a times a times a times a times a times a. Okay, if we will simplify, this will be cancelled. This one also. So in the denominator part, we have a times a times a times a. And this is equal to a raised to the power of 5. Numerator is 1. So we have 1 over a raised to the power of 5. Okay, this time, let's move on to the fourth exponent rule. And this is what we call the power of a product property or rule. Power of a product property or rule is similar to distributive property. Okay, m, or our exponent, is a natural number. Okay, I said it's similar to distributive property. Okay, how does it work? Okay, example. Or in our first example here, a, b inside the parenthesis, and it's raised to the power of m. M is our exponent. So this exponent, we have to distribute this to each number in the parenthesis. So we have a raised to the power of m and b raised to the power of m. Okay, what about if the number is a fraction? We have here a over b inside the parenthesis, and it's raised to the power of m. If the number inside the parenthesis is a fraction, we have to distribute this exponent to the numerator and the denominator. It's not only to the numerator or not only to the denominator, to both numerator and denominator. So this is, okay, a raised to the power of m, okay, over b raised to the power of m. Okay, let's give an example. Okay, we have here 2a squared inside the parentheses, and it's raised to the power of 3. Okay, this exponent 3, we have to distribute to each number inside the parentheses. So this is equal to 2 raised to the power of 3, and a raised to the power of 2 raised to the power of 3 is, so this is 3 times 2, so it's 6. So a raised to the power of 6. So we have 2 raised to the power of 3, a raised to the power of 6, or this is equal to 8a raised to the power of 6. 2 raised to the power of 3 is equal to 8. So 8a raised to the power of 6. Okay, what about this next example here? We have negative xy squared inside the parenthesis, and it's raised to the power of 3. If the number inside the parenthesis is negative, we also need to distribute the exponent to that negative sign. So that means, okay, this exponent will be distributed to this negative sign, and then this one to x, and then this one to y squared. So negative, and this is raised to the power of 3, that means still negative. Okay, what about this exponent 3 distribute to x? So this is x raised to the power of 3. Y squared, and then raised to the power of 3. So just multiply 3 by 2. So 3 times 2 is 6. So this is y raised to the power of 6. So we have negative x raised to the power of 3, y raised to the power of 6. Okay, let's try this simple activity. Okay, the first one, we have a, b inside the parenthesis, and it's raised to the power of 3. So we will distribute this exponent 3 to a and b. So we have a raised to the power of 3, b raised to the power of 3. Okay, the second one, ab squared inside the parenthesis, and it's raised to the power of 3. So this exponent 3 will be distributed to a and to b squared. So we have a raised to the power of 3. Okay, since b is raised to the power of 2, then this is also raised to the power of 3. Okay, 2 times 3 is 6. So b raised to the power of 6. And then a, just copy a raised to the power of 3. So we have a raised to the power of 3, b raised to the power of 6. Okay, number 3. Okay, this time, the given is a fraction. So we have to distribute this exponent to both numerator and denominator. A squared, so multiply 4 by 2. So this is, okay, so this is 4, and this is b raised to the power of 4. 4 times 2 is 8, so a raised to the power of 8, and then this b raised to the power of 4. Okay, this time, let's answer the following problems. The first one is a raised to the power of 11 divided by a raised to the power of x divided by a. And this is equal to a raised to the power of 4. The question is, what is the value of the natural number x? Okay, this one. And take note, this is an exponent. Okay, this one is equal to a raised to the power of 4. Since the exponent of a is 4, and this is a natural number, that means this exponent 11 is the highest exponent. So, this is division, and our bases are the same. In order to get 4 here as the exponent of a, that means we have here a, and then raised to the power of 11, okay, minus this one, x, plus what is the exponent of a? If there's no exponent written, that means the exponent is 1. So we have x plus 1, and this is equal to this exponent 4. Okay, what number are we going to subtract from 11 to get 4? So 11 minus what number? And the answer is 4. So this must be 7. So number plus 1 equals 7. So that means this is 6. So 6 plus 1 is 7. So 11 minus 7 equals 4. So that means x is equal to 6. Okay, let's have this second problem. X raised to the power of 2a, y raised to the power of b. This is inside the parentheses, and it's raised to the power of 3. This is equal to x raised to the power of 12, y raised to the power of 12. The question is, what is the value of a plus b for natural numbers a and b? Okay, this one is equal to this one. Okay, let's get this one first. We have x raised to the power of 2a, y raised to the power of b, and this is raised to the power of 3. Okay, if we will distribute this exponent to each number inside the parentheses, okay, that means, okay, this is equal to, okay, this one, so this is x raised to the power of 6a, because 3 times 2a is 6a. And then y raised to the power of 3b. Okay, this is equal to x raised to the power of 12, y raised to the power of 12. Okay, take note, this one is equal to x raised to the power of 12. And this one is equal to y raised to the power of 12. Okay, the exponents here are 12. So we are looking for the value of a and b. Okay, what will we multiply to 6 to get the answer 12? So that means a is 2, because 6 times 2 is 12. So a is 2. Okay, what about b? What will we multiply to 3 to get 12? So that means b is 4. So b is 4, because 4 times 3, 12. So what is the value of a plus b? So we have 2 plus 4. So our answer is 6. Okay, the third problem is this one. We have here 3x raised to the power of a over y raised to the power of 4. This is inside the parentheses, and it's raised to the power of 2. Okay, this is equal to bx raised to the power of 6 over y raised to the power of c. The question is, what is the value of a plus b plus c for the natural numbers a, b, and c? Okay, first, let's get this one. We have here 3x raised to the power of a over y raised to the power of 4, and this is raised to the power of 2. So this exponent 2 must be distributed to each number inside the parentheses, the numerator and the denominator. So 3 squared, this is equal to 9. Okay, what about x raised to the power of a? So that means 2 times a. So this is x raised to the power of 2a. Okay, over the denominator, so we have y, then 2 times 4 is 8. So y raised to the power of 8. Okay, take note, this is equal to, we have here b, x raised to the power of 6 over y raised to the power of c. Okay, now we know the value of b. b is equal to 9. Okay, what about c? Okay, now we know the value of c. c is equal to 8. So c is equal to 8. Okay, what about a? Okay, here the exponent is 6. So what will we multiply to 2 to get 6? So that means this is 3. 2 times 3 or 3 times 2 is 6. So a is equal to 3. The question is, what is the value of a plus b plus c? So we have 3 plus 9 plus 8, and this is equal to 20. So our answer is 20.